So to start off this tutorial, I'm going to show you two rigs. One of them that doesn't have a no-flip shoulder setup, and one of them that does. So this is the rig that doesn't have a no-flip shoulder setup. So when I twist the shoulder 90 degrees, you can see that all of the rotation occurs right here on the mesh. Instead of having the rotation distributed evenly along the entire upper arm section, it occurs right here at the shoulder, and it creates this kind of candy wrapper effect, which isn't desirable. And the reason that's happening is if you look at the orientation of the joints on the forearm, they all rotate together, instead of this one rotating just a little bit, this one rotating just a little bit, and this one rotating a little bit more, and just kind of spreading out that orientation. And so some of you might already be thinking that we could use the same kind of setup on the upper arm as you do on a shin or on a wrist. Because when we twist the wrist, it does evenly distribute the rotations along the axis, along the forearm, and the orientation of the joints looks exactly like what I wanted. The only issue with that is that shoulders have a much larger range of motion than a wrist does. So a wrist, so the system that we use to extract the twist on a wrist will actually break. Which axis does this one use? If we go past 90 degrees. So you can see that it's kind of broken here. Might be more noticeable if we go in this direction. Yeah, so you see it went this way and then it started to twist in the opposite direction. Now it tries to hold together, but the technique that's being used here just doesn't really work. And a shoulder has it a lot worse, because a wrist can pretty much go 45, 60 degrees in any direction on a real anatomical human, but your shoulder could go down 90 degrees when it's straight up against your body. It could come forward across your body more like 120 degrees, maybe even more. It could go backwards, and then it could twist as well. And also go up, but a lot of that motion comes from the clavicle as well. So we're going to need a different technique to extract the twist here on the shoulder than the technique that we use here on the forearm. And so I'm going to go into a different rig, and I will show you what that looks like in a final rig. So this is the rig that does have a no-flip shoulder setup. So you can see, when I come in here and I twist the shoulder 90 degrees, that twist is distributed evenly along the entire upper arm section, instead of just occurring here at the shoulder. And you can see that the orientation of these individual joints is responsible for that. They each rotate a little bit until they finally add up to the full rotation here at the elbow. And just to show you that I'm not accomplishing this using dual quaternion weighting, I'm going to select this guy, come over to the skin cluster, and you can see that I'm still using classic linear. I could do dual quaternion and get a little bit better volume preservation, but of course if I were to use dual quaternion, I couldn't scale the joints, and that's something that you want on a nice cartoony rig. And so most importantly, this works in any pose. I could bring the shoulder down 90 degrees and do that. Bring it up. Twist still works. I could bring it across a ton, so this is way out of the range. But the arm can actually work in functionally for deformation. But it still twists properly. The rig doesn't break. So now I'm going to go into another Maya file and I'll show you how to set up this technique. So to start off, we're going to create a little stand-in for a shoulder control. Give it a little FK control and color it green. And we're going to name it shoulder control. Then we're going to come down here and we're going to create another joint chain right on top of it, but a little bit shorter. And we're going to name this one twist reader base and twist reader tip. And I'm going to name this elbow joint, just so we remember that it's a stand-in for the elbow. And then I'm going to create an IK handle, make sure it's rotate plane, from the base to the tip. Put the IK handle, which we'll name twist reader IK handle, is a child of the elbow joint. So now, if I turn on the local rotation axis for the shoulder control and the twist reader base, you can see that they're perfectly aligned because we have this IK handle right here. They're just going to follow along together. But what we want is we want the shoulder control to be able to rotate any which way, and the twist reader will follow along by orienting along this bone segment, but we don't want it to twist along the primary axis, in this case the x-axis. So to make that happen, all we have to do is come over here to the IK handle settings and change the pull vector from 0, -2, 0 to 0, 0, 0. And that will turn the IK handle into what's called a quaternion aim. And so at the end of this part of the tutorial, I'll kind of go over what that means and what different systems of rotations look like in 3D, because I know that isn't exactly helpful to everybody. So now, whenever I twist in any pose, the twist reader base is unaffected by that twisting motion. It's only affected by the posing. And you can see that it actually does flip, so it's a bit of a misnomer, but it doesn't twist until we get to 180 degrees, so completely flipped around from where your shoulder is. And I don't know about you, but I can't take my shoulder and flip it 180 degrees so it's pointed into my body. So we've gotten as much range of motion as we could possibly need on a shoulder rig. But if we look at the twist reader base, you can see that we have 3 Euler rotations. We don't just have a single twist value. To get that, all we need to do is create a locator, make it a child of the twist reader base, so now it follows along with the twist reader base, and then we're going to parent constrain it with maintain offset off to the shoulder control. So basically what the locator is doing is telling us the difference in orientation between the twist reader base and the shoulder control, which of course the only difference between the two is this twist along the x-axis. So if we look at the locator here, we see 41 degrees, and that looks about right because the difference between those two z-axes looks about 45, a little bit less, and that's exactly what the locator has given us. So in order to distribute that rotation along this joint segment, we can do that using motion paths. At least that's how I do it, because I actually will put the twist on the bendy joints as well, so I have fewer joints to deal with. So let's create a curve, put it on here, and this bone is 8 units long, so the one in the middle will go right there. So I'll create a joint, select the curves, select the joint, select the curve, and I actually have a script to create the motion path, because the motion path tool up here actually creates some extra nodes that you don't need. So run that script, come over here to the joint, set the U value to 0.5, so now it's in the middle. Come on. And so you can see that this joint right now does not have the right orientation. We want it to have the same starting orientation as the shoulder joint, or the shoulder control. So to fix that, all we have to do is come into the motion path. We're going to change the world up type to object rotation up, and make the world up object the shoulder control. So now it's taking whatever the up axis is on the shoulder control and using that as its own up axis. But the actual up axis in this case is the Y one, so we'll change that from Z to Y. And the front axis is the X one, so we'll change that to X. So now it's pointed in that direction. And then the last thing that we need to do is we need to apply the twist. Because when I do this, it follows along completely with the shoulder control. But we actually only want it to follow along by 50%, because it is in the middle of the forearm. The joint down here would follow along 100%. So to do that, we're going to come into the node editor. We're going to bring in the joint and the motion path. And we're also going to bring in that locator that we use to extract the twist. Let's bring in all that stuff. And all we need to do is create a double linear node, or a multiply divide node if you're more comfortable doing that. We're going to set this to -0.5. It's negative because we're doing a counter rotation. Because you see, when we rotated this 90 degrees in this direction, we want this to rotate 45 degrees in the other direction. So we'll set that to -0.5. Take the rotate X off of the locator, because that's the extracted twist value. Then take the output and plug it into the front twist value on here. So now, let's see if that's worked properly. So when I twist this, it follows along 50% with the twisting of the shoulder control. And one step that I forgot to do is just select these two joints, select the curve, and skin it, so that whenever I pose it, that curve is going to move along with it. But anybody who has experience setting up bendy joint chains will know how to do that section of it. So if you want to get the final result that we had on the baby rig, you would just do the same setup with a motion path and a joint multiple times along this bone segment, and just give them different multiplication values here on the multiple linear node, on the double linear node, so that they would twist by a different amount as they move along here. And that's everything you need to know to set up a no-flip shoulder rig.